Imagine if you could make Oven Mini perform even better than Oven. Would you like that? Wouldn't that be awesome? So here on day 2 on 12 days of OpenAI's series of events, a new kind of fine-tuning method was launched, and it is reinforcement fine-tuning. So what is this reinforcement fine-tuning? Let's actually hear it from one of the team members.
So some of you will be familiar with the Supervised Fine-tuning API that we launched early last year. And Supervised Fine-tuning is really powerful. What you're trying to do is get the model to replicate features that it finds in input text or images. And this is great if you want to change the tone or the style or the response format of the model. Now, with reinforcement fine-tuning, or reindeer enforcement fine-tuning, as I should say, with reinforcement fine-tuning, it's different. So you're not just teaching the model to mimic its inputs. What you're teaching it to do is to learn to reason in entirely new ways over custom domains. And the way this works is that when the model sees a problem, we give it space to think through the problem, and then we grade the final answer from the model. And then using the power of reinforcement learning, we reinforce lines of thinking that led to correct answers, and we disincentivize lines of thinking that led to incorrect answers. And what you'll see is that, with as little as a few dozen examples, the model will learn to reason in new and effective ways over custom domains.
So if I had to explain to you what is supervised fine-tuning, what is reinforcement fine-tuning, I think the best example will be a student and a teacher scenario. So imagine you want a student to be trained to be very good in maths. So what you do is you take it to a teacher, and here the teacher is the grader, which actually grades the performance of the model. So what happens is you submit a bunch of questions and correct answers for that questions to grader, so that he can use it to train the model, just like we practice exercises in our schools and everything, just like that. So now what happens in supervised fine tuning is the grader asks the model that this is the question, come up with an answer. The model tries and comes up with an answer, and you see whether the answer is right or not according to what the guidelines were given. I said previously that the questions and the correct answer were also given. So the grader sees that if the model has given a correct answer or not. So if the model has not given a correct answer, he says that this is the wrong answer, please try again. So the model tries again, and then it comes up with a correct answer and says that very good. So he rewards the model when it gives a correct answer, and it punishes the model when it gets a wrong answer. So this is supervised fine tuning, but here the grader is not checking the steps. What are the steps the model took? Which is actually very important to understand whether the model is learning or not. Maybe it is just randomly guessing or using any kind of wrong trick to get up and accidentally getting to the correct answer. So in reinforcement fine tuning, what happens is same. The model is asked to try it and get the correct answer. So the model now gets the wrong answer, and now the grader checks the steps as well. So what are the steps been followed to get to the answer? And it punishes the model and says that do not use these steps, do not repeat this, it's a bad way of doing this. Then the model goes and tries again, and now it comes up with a correct answer. So now the grader says that okay, this is the correct answer. Remember the way you solved this because it is right. I've checked the steps, and also you've got the right answer. So what happens is the model is not only getting a practice of the correct answers for the questions, but is also understanding what steps to take. So if a question is a little bit out of what was given, it can make it out using the steps. So in simpler terms, this is reinforcement fine tuning according to what I can understand. So how the test data set, the set of correct answers and questions that were given, how does that look? Let me show you. So here you can see this is a training example, right? So let us understand for what kind of questions are they training this model in this particular case. So the case is that the model is to be trained in such a way that whenever symptoms and absent symptoms of a patient are mentioned, then the model has to predict the particular gene which is most likely causing this issue. So what they did in the training, they exactly replicated this, what they want to be done in the end case scenario. So they came up with case reports where there are people with symptoms and absent symptoms, and here you can see the instruction is please list all the genes that may be causing the symptoms in ranked order for most to least likely, along with an explanation for why you think those specific genes may be responsible. And you are also providing the correct answer. So when you are training, the grader will be having the correct answer with it, and these two instructions case report will be sent to the model. Then the model will come up with its answer, and the grader will compare it whether it's matching or not. If it's not matching, then it will punish the model, and the model will try again. So now, enough talk. Let's see actually how big of a difference does this bring. So now the team will be actually showing how O1 Mini performed before any kind of fine tuning, and how it performed after fine tuning, and how the O1 model, the full O1 model, how does that perform, so that we can compare these three models. So let's see.
All right, so we're going to pop over to the evaluations dashboard, which is a product in our developer platform that we launched earlier this year. There's a lot of numbers, but don't worry, we're going to go through all of them. So I've set up 3 different runs here. The first one was a run against our O1 model, which we released yesterday. The second was against O1 Mini, which was the starting point of our fine-tuning job. And then finally, the reinforcement fine-tuned O1 Mini. Now, we looked at the reward going up and to the right, but what does that actually mean for this task? I've set up 3 different evaluations to sort of assess that. The first one is top at 1, which is how often is the correct answer the very first item in the list. Top at 5, which is how often is the correct answer in the top 5 elements of the list. And finally, top at max. Did we at all put the right answer in our list? And so looking at top at 1, we can see that our starting point, O1 Mini, got 17%. On our data set of about 200. O1 got 25%, so it's doing better. But then our fine-tuned O1 Mini got 31%. I took a screenshot of this and I put it into ChatGPT and asked it to make me a plot, a Christmas-themed plot. And here's a nice visualization of those 9 numbers that we saw earlier. So you can see our starting point, O1 Mini, across top at 1, top at 5, and top at max. Our O1 model. And then finally, our best performing model, which is this O1 Mini fine-tune here in dotted red line.
So as you saw, if you just see top at 1%, you can see it nearly doubled when it comes to O1 Mini. When it compared from O1 Mini to O1 Mini fine-tuned. And it actually surpasses O1 as well, as you see in all 3 conditions, that is top at 1, top at 5, and top at max. So what are the actually benefits of having this reinforcement fine tuning? You might be knowing about Math GPT and many websites which actually are directly focused on solving max questions. So instead of trying to use the direct base models, you can actually fine tune over mini with a very large data set of questions, and you can just make it absolutely intelligent in max. You don't care about anything else. You don't need any kind of generalization, no other domains, whether it's biology or, as you saw, genetics. Nothing. You just need max. You also know the particular type of questions that you are going to provide on your website. So just completely train on that, and the model will absolutely ace it. And if you want to go even higher, instead of training O1 mini, you can directly train O1, and you can see it will go even higher. Since it's a bigger model, it can better understand things, and as you know, the bigger the better. So this is what reinforcement fine tuning was, which they launched, and they said it at the start. For general users, it will be available next year, and for some kind of researchers, they can contact OpenAI to get an early access. So, guys, this was day 2 of 12 days of OpenAI series, and this is what Sam has to say about day 3. I'm so excited for what we have to launch on day 3. So, what he's gonna launch on day 3, I'm getting excited. It has to be something interesting. If you enjoyed this video, do like this video and subscribe to my YouTube channel for more such updates, and I'll catch you guys in the next one.